Imagine waking up tomorrow. It's Monday, the 4th of August, 2025. You roll over, expecting the gentle morning light to creep through your window. But something is profoundly wrong. The light isn't the familiar, friendly yellow-white you've known your entire life. Instead, a deep, ominous, blood-red glow floods your room, painting everything in a sinister new color. You stumble to the window, shielding your eyes, and peer outside. The sky is not blue. It's a bruised, angry crimson, and hanging there, impossibly large, is the sun. It's no longer a brilliant, distant disk. It has swelled into a monstrous, fiery orb that fills a huge portion of the sky, its edges looking fuzzy and turbulent, like a celestial bonfire. This isn't a dream. This isn't a special effect from a Hollywood blockbuster. This is the shocking new reality. Overnight, without any warning, our steadfast, life-giving star has entered the next phase of its life. The sun has begun its transformation into a red giant. The immediate change is not just visual, you can feel it on your skin. An intense, dry heat is already baking the air, a heat far more powerful than the most blistering summer day you have ever experienced. The birds are silent. The usual morning traffic is eerily absent. A collective planet-wide gasp is being held as 7 billion people stare at the sky in disbelief and terror. So what exactly is this cosmic monster our sun has become? In simple terms, a red giant is what happens to a star like our sun when it starts getting old. Think of a star as a car on a very, very long road trip. For most of its life, our sun has been cruising along comfortably using a specific type of fuel, hydrogen. In its core, it has been fusing hydrogen atoms together to make helium. This process, called nuclear fusion, releases an enormous amount of energy. This energy pushes outwards, perfectly balancing the immense inward pull of the star's own gravity. This beautiful balance is what has kept our sun stable and a consistent size for the last 4.5 billion years. But just like that car on a road trip, a star's fuel tank isn't bottomless. A red giant phase begins when the star has used up most of the hydrogen fuel in its core. The engine starts to sputter. With less outward push from fusion, gravity begins to win the cosmic tug-of-war. The core, now mostly full of helium ash, starts to collapse and get incredibly hot and dense. This is the star's midlife crisis. The party in the core might be over, but the drama is just beginning. The intense heat from the collapsing core ignites the remaining hydrogen in a shell surrounding it. It's like finding a spare jerry can of fuel in the boot of the car. This new, shell-burning phase is ferociously energetic, even more so than the original core-burning phase. The sheer amount of energy produced pushes the star's outer layers outwards with incredible force. To truly grasp this incredible transformation, we need to pop the hood and look at the sun's engine, its core. For billions of years, this core has been a place of perfect equilibrium. Gravity, the universe's great compressor, relentlessly tries to crush the sun into a tiny ball. At the same time, the nuclear fusion furnace in the core, converting hydrogen to helium, generates a tremendous outward pressure. This pressure, known as radiation pressure, pushes back against gravity. For most of a star's life, these two forces are locked in a perfect cosmic stalemate. This stable state is called the main sequence, and it's where our sun has happily spent its entire existence until this fateful morning. The trigger for the red giant phase is fuel starvation. The core of the sun eventually runs out of hydrogen to fuse. It's like a bonfire that has burned through all the big logs at its center. Without the outward push from fusion, gravity instantly takes the upper hand. The core, now composed of the helium ash created over billions of years, begins to collapse under its own immense weight. As it collapses, the pressure and temperature skyrocket to unimaginable levels. We're talking over 100 million degrees Celsius. This process is governed by a simple rule of physics. When you compress a gas, it heats up. Now, this superheated, collapsing core acts like a new secondary furnace. While the core itself is out of hydrogen, there's still a thick shell of unused hydrogen surrounding it. This sudden, massive increase in outward energy pressure is what overwhelms gravity's pull on the star's outer layers. This is the moment of inflation. The moment the sun explodes into its red giant phase, the clock starts ticking for Earth. But we wouldn't know it instantly. Light and gravity, The two messengers of this cosmic event travel at the same speed, approximately 186,000 miles per second. Given that Earth is about 93 million miles away from the Sun, this means we have a brief, blissful period of ignorance. For about 8 minutes and 20 seconds, everything on Earth would seem perfectly normal. People would be going about their morning routines, completely unaware that a wave of annihilation is racing towards them at the speed of light. Then it arrives. The first sign would be the sky. It wouldn't be a gradual change, it would be a sudden jarring shift. The familiar blue sky, created by the scattering of shorter wavelength light, would vanish. The new, larger sun would be pumping out light predominantly in the red part of the spectrum. The sky would instantly turn a deep, dark, angry red. Simultaneously, the sun in the sky would visibly swell. It would no longer be a small, manageable disk you can block out with your thumb. It would appear as a monstrous, fiery sphere, taking up a terrifyingly large portion of the visual field. The sheer sight would induce worldwide panic. At the exact same moment, the heat would arrive. This wouldn't be a gentle warming. It would be like opening the door to a planetary-sized blast furnace. The sun's luminosity would have increased dramatically, and even at 93 million miles, the intensity of the radiation would be catastrophic. The temperature would begin to rise at an alarming rate, not by degrees, but by tens of degrees every minute. The air itself would feel like it was cooking. Anything flammable and exposed to the direct glare of this new sun would begin to smolder and spontaneously combust within minutes. The side of the Earth facing the sun would be flash-fried. Communication satellites, solar panels, and exposed infrastructure would be instantly fried by the intense bombardment of radiation and energetic particles. Once the initial shockwave of light and heat hits, the Earth's systems would begin to fail in a spectacular and honestly terrifying cascade. The planet's weather, which is usually this delicate dance of temperature and pressure, would be thrown into utter chaos. The side of the Earth facing the red giant would be subjected to temperatures soaring into the hundreds of degrees Celsius. This immense temperature difference between the day side and the night side would create windstorms of, unimaginable violence. Hurricanes with wind speeds exceeding 1,000 miles per hour would scour the globe. Gigantic firestorms would erupt, and the atmosphere would be choked with soot and ash. The oceans, the cradle of life on Earth, would face their end. The surface waters would heat up rapidly, far beyond their boiling point. The top layer of the ocean would literally boil away into the atmosphere, creating a superheated, high-pressure steam blanket around the planet. This would trap even more heat, accelerating the process in a runaway greenhouse effect on steroids. All surface-dwelling marine life, from plankton to great white sharks, would be killed almost instantly. The deeper parts of the ocean would warm more slowly, but their fate would be sealed. The entire planetary water cycle would be broken, replaced by a cycle of flash boiling and steam. For the planet's flora and fauna, the apocalypse would be, swift and absolute. Plants would be the first to go. Unable to escape the searing heat and intense radiation, forests, grasslands, and jungles would be incinerated. They would turn from green to brown to black in a matter of hours, consumed by continent-spanning wildfires. Animals would face a similar fate. Those not killed by the initial heat blast would be hunted by the raging firestorms or suffocated by the toxic, superheated atmosphere. There would be no shelter, no hiding place. The very ground would become too hot to stand on. The intricate web of life, built over billions of years, would be undone in a day. For humanity, the sudden arrival of a red giant sun would trigger a response born of pure primal survival instinct. The initial moments of disbelief would give way to sheer, unadulterated panic. Governments would collapse, communication systems would fail, and the delicate structures of society would crumble into dust. The only goal for every single person would be to escape the direct, searing gaze of the new sun. A desperate, chaotic migration would begin, honestly the largest in human history, as billions of people on the sunlit side of the planet desperately try to get to the night side. This would be a futile race against time. The only conceivable places for short-term survival would be deep underground or at the bottom of the ocean. Humanity would scramble for the deepest mines, the most extensive cave systems, and military bunkers built for nuclear war. These places might offer temporary shelter from the scorching surface temperatures. Submarines could dive to the crushing depths of the ocean, where the water temperature would rise more slowly. But these would be temporary refuges at best. Without a functioning surface world, there would be no way to produce food, purify air, or maintain the technology needed to survive in these extreme environments for long. Scientists and engineers, in a last, desperate act of ingenuity, would look to the stars. But the challenge would be insurmountable. We currently have no technology capable of moving 7 billion people off-planet, let alone in a matter of hours or days. The dream of colonizing Mars or the moons of Jupiter would remain just that, a dream. Even if we had pre-built habitats on other worlds, the logistics of evacuating even a tiny fraction of the population would be impossible. Ultimately, humanity's struggle would be a tragic and short-lived one. The few who found temporary shelter deep underground would eventually succumb to starvation, suffocation, or technological failure. While this scenario is a terrifying hypothetical for us, it is a very real destiny for countless stars across the universe. By looking through our powerful telescopes, we can see this exact process playing out in distant star systems. We are, in effect, watching cosmic ghosts and previews of our own future. One of the most famous examples is the star Mira in the constellation Cetus. Mira is a variable star that is already in its red giant phase, and it has a fascinating trick. It pulsates, growing brighter and dimmer over a period of about 332 days, and it has been observed shedding its outer layers, leaving a spectacular tail of material behind it that is an incredible 13 light-years long. Another stunning example is Betelgeuse, the bright red star in the shoulder of the Orion constellation. Betelgeuse is a red supergiant, a much more massive version of what our sun will become. It is so enormous that if you placed it in the center of our solar system, its surface would extend out past the orbit of Jupiter. In late 2019 and early 2020, Betelgeuse mysteriously dimmed, leading many astronomers to speculate that it might be about to explode as a supernova. While it has since brightened again, it served as a powerful reminder that these stellar giants are unstable and nearing the end of their lives. Betelgeuse is a ticking time bomb, and when it finally goes, it will be visible from Earth even during the daytime. By studying these and other red giants, astronomers can piece together the story of our sun's future. They use techniques like astroseismology, studying the starquakes or pulsations of stars, to understand their internal structure. They analyze the light from these distant stars to determine their chemical composition, their temperature, and how fast they are losing mass to space. Each red giant we observe is like a page from a celestial instruction manual, showing us step by step what happens when a star exhausts its primary fuel source. It's cosmic archaeology, but in reverse, we are digging into the future, not the past. In the terrifying scenario of an overnight transformation, Earth's ordeal would not end with it becoming a scorched, sterile rock. The final act of this cosmic drama would involve the planet's complete and utter destruction. As the sun continues its expansion as a red giant, its physical size would grow relentlessly. Day by day, the monstrous red orb in our sky would get larger and larger. The distance between the Earth and the sun's fiery surface would shrink. The temperature on Earth, already hundreds of degrees, would climb into the thousands. The planet's surface rock would begin to melt, turning the entire world into a sphere of molten lava. As the sun's outer atmosphere, its chromosphere, expands, it would eventually reach Earth's orbit. At this point, Earth would no longer be orbiting near the sun. It would be orbiting inside it. The planet would be subjected to incredible atmospheric drag from the sun's thin, superheated gases. Imagine trying to run through water instead of air. The resistance is immense. For Earth, this solar drag would cause its orbit to decay. Slowly but surely, the planet would begin to spiral inwards, drawn closer and closer to the sun's incredibly hot and dense core. The end would be near. This inward spiral would be a journey through hell. The immense gravitational forces of the sun would exert powerful tidal forces on our molten planet, stretching and squeezing it as if it were a piece of cosmic putty. These tidal forces would generate even more heat within the Earth's core, accelerating its demise. The planet, once a vibrant world of oceans, continents, and life, would be reduced to a teardrop-shaped blob of incandescent magma, screaming through the outer layers of its parent star. Eventually, after a period of spiraling ever closer, the Earth would be completely vaporized. The elements that once made up our mountains, our oceans, our cities, and ourselves would be torn apart atom by atom and absorbed into the fiery mass of the sun. Contemplating such a cataclysmic, albeit fictional, event serves a profound purpose. It acts as a powerful reminder of our place in the universe. We live on a tiny, fragile oasis of life in an ocean of cosmic violence and indifference. The laws of physics that govern the life and death of stars are relentless and awe-inspiring. They operate on scales of time and energy that are almost beyond human comprehension. The stability we take for granted, the constant warmth of the sun, the predictable cycle of day and night, is a precious and temporary gift. This thought shouldn't inspire fear, but rather a deep sense of wonder and appreciation for the here and now. This extreme thought experiment also highlights the incredible importance of science and space exploration. It is through the patient work of astronomers, physicists, and scientists from countless other fields that we can even begin to understand these cosmic processes. Every telescope we build, every space probe we launch, every equation we solve gives us a clearer picture of the universe we inhabit. Understanding the sun's life cycle isn't just an academic exercise, it's the ultimate survival guide for our species in the very long term. It tells us about the ultimate fate of our home and underscores the necessity of looking beyond it. Exploring space is not a luxury. It is a fundamental human imperative, driven by the same curiosity that led our ancestors out of the caves and across the continents. By studying other planets, other stars, and other galaxies, we learn more about our own world and the conditions that make life possible. It is the only path that could, in the distant future, offer our descendants a chance of survival when our sun does eventually, and inevitably, begin its true red giant transformation. The challenges are immense, but the alternative is to remain on one planet, subject to the whims of a single star. So, while we are safe from an overnight solar explosion, the story serves as a cosmic wake-up call. It urges us to look up at the sky not just with passing curiosity, but with a profound sense of connection and urgency. The universe is a magnificent, dynamic, and sometimes terrifying place. By striving to understand it, we not only secure our future but also enrich our present, deepening our appreciation for the beautiful, fleeting moment we have on this small blue world, orbiting our friendly middle-aged star. The stars are not just distant lights. They are a map to our past and a signpost to our future.